Namaste everyone. Here is a problem. A given coin has a mass of 3 gram. Calculate the nuclear energy that would be required to separate all the neutrons and protons from each other. For simplicity, assume that the coin is entirely made up of copper atoms. Of course, this 3 gram coin is made up of copper. So you will have to find out what is the total energy required to separate all the protons and neutrons of this 3 gram coin. So the simple method is, first of all, calculate what is the energy required to remove protons and neutrons from one atom of copper. That is nothing but binding energy of copper. So binding energy of copper is the energy required to separate neutrons and protons from one atom. It is the binding energy of one atom. So then calculate how many atoms are there in 3 gram coin. Multiply that binding energy to the number of atoms in 3 gram coin. Now how to calculate binding energy of copper? You have to start from the mass defect. Mass defect is Z into mass of proton plus A minus Z into mass of neutron minus the mass of the nucleus. We know it. Now in copper, it is atomic number is 29 and mass number is 63. So this is A and this is Z. So if you substitute the values, the mass defect is Z into mass of proton. Z is 29 into mass of proton. Mass of proton is given 1.007825. So we will get the total mass of all the protons plus A minus Z into mass of each neutron. A minus Z is 63 minus 29. 63 minus 29 will give the number of neutrons into mass of each neutron, 1.008665. 1.008665 minus mass of nucleus. Mass of nucleus is 62.92960. So all masses are in atomic mass unit. 62.92960. Yes. Now, if you want to calculate this, delta M is equal to, we'll use the calculator. Yes. 29 into, so 29 into 1.00, 7825, 7825. 29 into 1.707825. That comes to 29.226925. 29.226925. 29.226925 plus, okay, 29.226925. Okay. 63 minus 29. 63 minus 29, that is the number of neutrons, into 1.00, 665 mass of each neutron. That comes to 34.29461. 34.29, 34.29, 34.29, 461 minus mass of the nucleus 62.92960. Okay. Now we will add this to 29.226925. 29.226925. Okay. That is equal to, so already it is added to 34.29461 minus this 62.960. That is equal to, so that comes to, no, this is wrong. We'll calculate it again. 29.226925 plus 34.29461 29461 is equal to minus 62.92960. That comes to 0.591935. So delta M is equal to 0.591935. 0.591935. That is atomic mass in it. That is mass defect. Now, if you want to know what is the binding energy, you know that binding energy is delta M into 931.5 million electron volt. So binding energy is 0.591935 into 931.5 million electron volt, 10 to the power 6 eV. Binding energy is so just multiply this number to 931.5 million electron volt. So that comes to 551.387, I'll write 387 into 10 to the power 6 electron volt. This is the binding energy of one copper atom. Energy required to remove the protons and neutrons in one copper atom. But you have 3 gram mass of copper coin. How many atoms are there? Multiply to this then. How many atoms are there in 3 gram copper? Now, 63 gram copper has Avogadro number of atoms. Its mass number is 63. Here we have it. So 63 gram contains Avogadro number of atoms, 6.02 into 10 to the power 23. What about 3 gram? This gives number of atoms in 3 gram copper. So that comes to, so N is equal to, clear, 6.02 into 3 divided by 63. So that comes to 0.2867, I'll write. 0.2867 into 10 to the power 23 atoms. So one atom needs this much of energy to separate all the neutrons, protons. What about these atoms? So total energy required to separate all the neutrons and protons of 3 gram of copper is 551.387 into 10 to the power 6 into 0.2867 into 10 to the power 23. So that comes to, that is equal to, we will keep this million electron volt as it is. So 551.0.28667, it is here only. So into 551.387. That comes to 158.06. 158.06 into 10 to the power 23 into 10 to the power 6 electron volt. So the total energy required to remove the neutrons and protons of 3 gram copper is 158.06 into 10 to the power 23 million electron volt, because 10 to the power 6 I have taken it as 10 to the power 6 has taken as million. So that is the answer. Yes. Thank you.